Limits of a multi-rule function. Find the limit from the left side and the right side first to see if they are equal to find the two-sided limit. So I have a piecewise function, also known as a multi-rule function. It looks like very interesting things are happening at x equal to 2 because I've got a rule for x is greater than or equal to 2 and a rule for x is less than 2. And so it's saying find the two-sided limit. Well, as x is approaching 2 from the left, I'm going to use this rule because this is where x is less than 2. I know that x cannot equal 2, but what if I were to substitute into this equation? I'm interested in knowing where is the y going? Well, if I put an input of 2, 2 squared is 4 plus 1, y is going towards 5, even though it can't equal 5 because I don't have less than or equal to. I just got less than. So I'm going to have an open circle there at, well, x is headed toward 2 and y is headed toward 5. So I get this point 2, 5. What if I did the same thing for this top equation where x can actually equal 2? So I'm saying substitute here and we get, as x is going towards 2, we get 3 times 2 minus 1, which is 6 minus 1, which is 5, which shows us when x is going towards 2, y is going towards 5. In fact, we have that point. So what's the limit? Well, they're both headed towards 5. So I know the limit is 5. If I were going to draw a sketch of this particular piecewise function, it might look something like this. X squared plus 1, I know we're elevated 1 and it's this parabola shape. I'm only allowed that for x is less than 2. So here's my interesting point, x equals 2. And so I'm not allowed anything to the right of that. And in addition to that, the red function is going to have an open circle here at 2, 5. The blue function has a y-intercept of -1 and a slope up 3 over 1, up 3 over 1. But I'm only allowed to use that from 2 and to the right. So you can see I have a dark circle and I'm going to the right here. And all of this dotted line has got to be erased because I'm not allowed that. That's not in the domain of this part of this piecewise function. And now I'm saying with this graph, as I pinch in on 2, where is the y headed? Well, the train from the left is going to be equal to the train from the right. They're going to the same station, which is 5. Notice the limit comes from the y-axis. We're looking, where are these two headed? Here we're given a piecewise function. F of x is -5x plus 3. That's linear because this is to the first power. So we know that this is a line where x is greater than 1. And parabola shape, 2x squared plus 1, when x is greater than or equal to 1. I'm sorry, this should be less than 1. All right? So, of course, look at where the interesting part is. The graph changes at x equals 1, and they, of course, want to find the limit as x approaches 1 from both sides. So, if I'm given something like this, I don't even have to graph it. I can just say, well, where is y headed in each case? If I take that top equation, and I substitute in, I know it's not less than or equal to, but if I put in a 1, -5 times 1 plus 3 is -5 plus 3 is -2. The y is heading towards -2 there. And the bottom equation of this piecewise function, if I plug in a 1, 2 times 1 squared plus 1 is going to give us 3. Look, the left-hand limit and the right-hand limit are not the same. They're not headed to the same space. So of course this is D and E for does not exist. If I wanted a sketch of this, this is a line for x is less than or equal to 1. It has a y-intercept of 3 and a slope of -5 over 1. So here would be the potential y-intercept, and I'm interested in this spot where x is equal to 1. So if that's the case, I'd be going down 5 over 1, and the line would look like this. So at 1, we're going to have a -2. So we're down here. Of course, it's going to be an open circle and it has a y-intercept of 3. It's going to look something like this. The other function is only from x equals 1 and to the right, and it's a U-shape with a vertical shift of up 1. So it's going to look something like this. And I'm only allowed from this point on. You can see, here's our point. Here is a piecewise function. Again, we don't even have to graph this to find the limit. If I put in 1 for this top function, I get -5 times 1 plus 3 is -2. And if I put in a 1, the point of interest for this bottom function, I get 2 times 1 squared plus 1 is 3. Now, of course, if 1 is the point where we're switching over from one function to another, they're going to ask us the limit as x approaches 1 from both sides of f of x. And we can plainly see that this function is heading towards -2 and this function is heading towards 3. Because they don't agree with each other, we can just say does not exist. Now, what does this look like graphically? We can confirm that with the graph, but we don't even need to graph that. So y equals -5x plus 3. And we know with this red function, we've got this point over 1 down 2, over 1 down 2. It's an open point because x cannot equal 1. And here is our -2. And the slope is -5 over 1. So it's something looking like that. And here is x squared plus 1 with a vertical stretch by factor 2. And it goes to this point when x is 1, y is 3. So there is that point, and it's going to look something like this. Notice when x is 0, y is 1 there. And so if we're looking at the limit as x approaches 1 from both sides, clearly these limits, the left-hand limit does not equal the right-hand limit. That's why we can say does not exist. I don't even need this graph. I can just look at the function values at the point of interest and say, these are not going to the same place on the y-axis. They're not trending towards the same y. The left-hand limit does not equal the right-hand limit. Here we have a piecewise function split up 3 ways. F of x equals this function when x is less than -1. F of x equals 6 when x is equal to -1. So that tells us we've got a point -1, 6. And x is equal to this linear function. I know linear because it's to the first power when x is greater than 1. Well, what if I plugged in -1 there? 2 times -1 squared. Where is y heading? -1 times -1 is 1 times 2 is 2. Y is heading towards 2. Y is heading towards 2. Y is at 6. And if I put a -1 in here, 2 times -1 plus 3 gives us -2 plus 3 is 1. So look, the y values from the left and right are heading towards different values. As x heads towards -1 from the left, y is heading towards 2. As x heads towards -1 from the right, y is heading towards 1. And the actual value is 6 there because we've got holes here and here. Clearly does not exist. And here's our graph of this. Look, as x comes in from the left, y is heading towards 2. As x approaches -1 from the right, y is heading towards 1. And the actual function value is up at 6. So clearly does not exist. The right-hand limit does not equal the left-hand limit.